T minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. Liftoff. Liftoff. And liftoff.
Hello, welcome everybody. Today we're going to be asking, hey, what's up with the universe? Yep, we are back. Today we are going to be talking about a very important piece of space instruments. Yes, we are actually going to be talking about the Hubble Telescope. Yes. I know many people is like, hey, yeah, I heard about it, but have you actually heard about the Hubble Telescope? Yeah, I know. I actually found it very fascinating to do some research on this. And I want to say hi to people who are in the chat right now. Hey, Pixel8. Hey, Mountains of Elysium. Welcome back. Hey, Jeff B. Let's light this candle exactly as Mr. Kirby used to say. I mean, the Hubble Telescope, basically, it's orbiting high above the Earth, and it basically it's an altitude about 353 miles, which is 568 kilometers for everybody who doesn't use the American measurement system. Or as 14 Barber says, 4,238 washing machines long. Okay, high up. So, but of course, this orbit does decay over a period of time. That means a decision is looming for NASA regarding how long this telescope is going to be operational and actually scientifically productive. And in case you're wondering how heavy it is 24,493 pounds. Yep. That's a big, little heavy little sucker. The Hubble is a case-grain reflector telescope, which means light from celestial objects travel down a tube and is collected by a bowl-like, inwardly curved primary mirror and reflected toward a smaller drone-shaped, outwardly curved secondary mirror. The secondary mirror, it basically bounces light back and forth through a little hole in the center. The light is focused on a small area called the focal plane. It's where it's picked up by various scientific instruments. I forgot to tell you how long it was. It's 7.8 feet long, which is 2.4 meters long. The diameter primary mirror, it collects light from its from basic target and reflects it onto a 12-inch diameter secondary mirror located in the optical tube. Oh, sorry, I forgot. 0.3 meters. Yes, I know, the power of math. This secondary mirror located in the optical tube, it reflects light through a hole and the primary mirror to an image of the secondary's focal plane. Of course, the Hubble mirrors are made of an ultra-low expansive glass. It's kept at a room temperature at about 70 degrees Fahrenheit or 21 degrees Celsius to avoid the warping. Yeah, we're going to talk about that. The outside of the mirror is called reflecting surfaces. It's coated with, get this, 3 100,000th inch layer of pure aluminum and protected by 1/100,000th inch layer of magnesium fluoride. It also makes the mirror more reflective to ultraviolet light. As you can see here in the diagram, you got the primary mirror in the front of everything, and you got the solar panels as well. If you want to look at this diagram, you can go ahead and pause this video if you're watching live. If you're watching this on a stream, you can pause this for a moment, and I'll take a little moment so you can actually read this. If you're doing this on a rewatch, if you're watching this live, you can actually read the little instruments here while I take a drink of my invisible soda. Okay, I feel better. I mean, Hubble's current suite of instruments, they basically include the Wide Field Camera 3, which is the WFC3, the Cosmic Origin Spectrograph, the COS, the Advanced Camera for Surveys, the ACS, the Space Telescope Imaging Spectrogram, the SCIS. I told you I love the acronyms. And of course, the FGS, which is the Fine Guidance System. The spacecraft system itself, the Hubble's control and support system, and the damage instrument diagram, the forward shell houses the telescope's optical assembly. The middle part of the telescope is where the reaction wheels and the bays that house the observatory control electronics. Basically, it's where the telescope sees. The communication antennas, Hubble performs in response to detailed instructions from people on the ground. Basically, yeah, we can tell Hubble what to do and where to go and where to see. And I'm going to include in the description after the video on how to actually try to obtain telescope time on Hubble itself. Yes, there is possibilities. Let's see. We would not have the Hubble telescope if it wasn't for Edwin Hubble. Yep. With the with the 2.5 meter telescope at Hooker Telescope at Mount Wilson in Pasadena, Edwin Hubble was the first person to actually measure the distance and velocities of galaxies. It basically led to the working theory that led to the discovery of the expanding of the universe. In 1923, he spent months and months collecting various data about large known spiral nebula, which basically led him to conclude that Andromeda is not a nebula after all, but a galaxy instead, just like our own. And of course, it basically opened the scientific views that, hey, the Milky Way galaxy is not the universe. It's a multitude of galaxies. Our whole entire world just expanded thanks to Edwin Hubble. He was basically able to make these calculations by measuring the variations of the luminosity, which is the length of time it takes a star to go from bright to dim and back again. Variable stars in the Andromeda galaxy, based on a formula developed in 1912 by the Harvard computer Henrietta Leavitt. Yes, she was known as the human computer. She was very good. Sorry, what did you say, mountains? The camera on the New Horizons is now being used to measure different light, and the new measurement has increased the believed number of galaxies by at least 100%. Awesome sauce! See, I love science news. Where was I? Oh, yeah. I was talking about that guy, Edwin Hubble. When Hubble did his little calculations, he calculated that Andromeda is approximately 900,000 light years away, which is more than 8 times the distance to the farthest known stars in our own Milky Way galaxy, which basically proves that Andromeda is a separate star system and the Milky Way is not the sum of the whole entire universe. He expanded our knowledge. I mean, for this reason alone, and of course many of his other accomplishments, they officially named the telescope in 1983 after him. I mean, work began on the Hubble Telescope in 1979. It's a 7.9-foot meteor, or 2.4 meteor for non-Americans. Yep, I'm talking to you, Joseph. It basically, the optics company Perkin-Elmer was commissioned to build the optical telescope, the OTA, and the FGS, the fine guidance sensors. The mirror polishing basically took a long time to do. It took several years. It was completed in May 1981. How old were you in 81? In 1983, the dedication to the Hubble Space Telescope is when they actually honored him. April 24th, 1925, 1990. The Hubble Space Telescope was launched from the Kennedy Space Center and deployed. Such a beautiful liftoff. I watched that on television when I was a child. I'm sorry, I love that. The more than 40 years after it was more than 40 years after it was conceived, basically, NASA's Hubble Telescope was launched into Earth from the Kennedy Space Center. A day later, astronauts guided a 43-foot, 12-ton telescope from the cargo bay of the Space Shuttle Discovery out into an orbit of 332 miles above Earth's surface. And no, I did not calculate kilometers for a reason, because I'm American right now. I mean, in addition to this 92-inch primary mirror to collect light, the fine guidance sensors to point and lock onto targets, and the solar primary panels power, the original Hubble's configuration included 4 key scientific instruments: the HSP, the WFPC, known as the WFPC-1, the FOC, and the GHRS. Oh yeah, acronyms. The HSP stands for High Speed Photometer. The WFCP was the Wide Field Planetary Camera. The FOC is the Faint Object Camera. And the GHRS is the Goddard High Resolution Spectrograph. This is why I love acronyms. Get this. In May 20th of 1990, Hubble saw its first light. This is the first image right here. Check this out. This is the very first image from the Hubble Telescope. On the right side of the image, it's taken with the HCS, the Wide Field Planetary Camera. It is shown with a ground-based picture from Los Campanas, Chile. I always hate pronouncing that. Sorry, Chileans. It was taken with the 100-inch telescope, of course. This is, as you can see, at left and right. So, sorry, lost track of my time for a second. Place both sides of photographs of the same region taken with a slightly larger ground-based telescope. On June 1990, they discovered a flaw in Hubble's primary mirror. Yeah, I told you I would get to this. After analyzing the telescope's first images, they realized that they had a flaw known as a spherical aberration. Basically mean the Hubble telescope needed contact lenses. I mean, they revealed that during its manufacturing, during the making of it, I'm sorry, you can't see me. During the manufacturing of the making of the mirror, they found out that the outer edges of the mirror was grounded too flat, basically about 4 microns, which is about 1/50th the thickness of a human hair, I believe. Please correct me if I'm wrong. It basically, that the way the mirror was flattened, it scattered light, so they really got fuzzy images. It was not returning all the pictures everybody wanted. I mean, the STSCI covered planets, hot stars, cool stars, but they really couldn't get any solid, good images. See, as you can see right here, this comparison of the core galaxy M100, they actually show their improvement. The left-hand side of the picture is what the original was. When they actually corrected it, they got a sharper image. This was basically 1993. And get this, they also found a supernova ring. Yep, supernova 1987A. Ring resolved. What does this mean? Hubble resolves to an unprecedented detail of a 0.1 arc second. It's a mysterious elliptical being of material. Basically, this invisible light that we could not see with our own eyes clearly shows an elliptical luminescent ring of a gas that extended about 1.3 light years across the surface, across the surrounding areas of the explosion. The scientists actually believe that the ring is a relic of hydrogen-rich stellar envelope that was ejected from the core of the star by a gentle solar wind. They estimate this to be about 10,000 years ago. The gas was subsequently swept and compressed into a narrow, high-density shell by a high-speed stellar wind ejected from the star when it evolved back into blue supergiant stage. I mean, this imagery here that Hubble took, it suggests that the star was more efficient at compressing gas along with an equilateral plane to create a ring-like structure. I mean, because this ring is inclined along the line of a straight line, it actually has an elliptical appearance. According to Bird, it's probably pronounced supernova. I am in the chat file, Mike. And sorry, I did not speak Espanol. Okay, I speak a little bit of Spanish, and I do read the chat. Because Jason State said, hey, Mo. Yuck, yuck. Okay, on that note, we are going to take a quick little commercial break, okay? I'll be back in just a few moments, guys.
Hey guys, LDG Pixels here. If you have issues with your computers, have any IT questions, come join us at YouTube at LDG Pixels. That's on YouTube, LDG space Pixels. I'm live. I'm here to help. Tech news, nerd chat, help you fix up your computer free.
Okay, now that we're back here, we're going to continue talking about more of Hubble's discoveries, since I actually do read the chat. Yes, I do. We are going to be talking about what happened on May 17th, 1991. What happened on May 17th, 1991? Hubble took its very first image of Jupiter. Yes, this is an actual image. It's a black and white picture of Jupiter. It was the very first one taken that basically showed the Jovian weather on its side. It was taken in a green light at 1:14 a.m. on the 11th of March in 1991 by the planetary camera. See, I didn't acronym that for you. As you can see on the bottom, the dark J-shaped clouds along the equator are the result of a pattern of intense jet streams in the Jovian atmosphere. This picture was sharper than the Voyager picture took 5 days before, in 1979. And in January 13th, 1992, Hubble identified the nearby intergalactic clouds for the very first time. It was proven there are intergalactic clouds, and I can't talk still. Why? I mean, what scientists thought would be randomly disturbed nearby primordial clouds of hydrogen may actually be associated with galaxies or clusters of galaxies. I mean, until the launch of Hubble, it was basically impossible to directly measure the number of intergalactic clouds. If you don't understand this diagram, I'll explain it to you. The top diagram itself, the blocks schematically represent a column of space between a distant quasar and a telescope on Earth. The bottom one, Hubble's telescope dramatically changed this picture in 1991 when independent observations made with the HTS, OS, and the GHRS detailed more than a dozen hydrogen clouds within less than 1 billion light years within our own galaxy. Yep, this is a major milestone discovery. I left this up here so you guys can actually read this out a little bit. On November 19th, 1992, a giant disk of cold gas and dust fused, possibly black hole at the center of the core of NGC 4261. This is about 300 light years across. This disk right here, it's tipped enough, about 60 degrees, to provide astronomers with a clear view of a bright hub, which they still have not actually confirmed that this is a black hole in this or not. But there's speculation that every single major galaxy has a supermassive black hole, but they have not proved that this one has one yet. The disk of this core is in a Virgo cluster. It's about 45 million light years from Earth. Dr. Walter Jaffe of the Leiden Observatory in the Netherlands, he said the disk is tipped about 60 degrees. This is what he said. He said the nucleus is probably the home of a black hole with a mass of 10 million times that of our sun. On the left side of the picture is a ground-based composite, the optical radio view of the elliptical galaxy. On the right-hand side is the HTS image of the core of the NGC 4261. See, I'm not getting that technical for you today. Ain't I nice? Of course, we're going to fast forward a little bit to June 9th, 1993. Hubble took a major step in determining the universe's age. I mean, astronomers using Hubble's, they basically announced they had determined a much more precise distance to galaxy M81, finding it to be about 11 million light years away. Previous estimates had ranged from about 4.5 million to 18 million light years away. We didn't know until June of 1993. With only precise distance measurements to galaxies, can astronomers actually refine the universe expansion rate and turn its age? Today, the estimated age of the universe is about 13.5 to 14.2 billion years old. Depends on what astrophysicist you talk to. That's a general consensus about the time. The team basically discovered variable stars in its first targets. The spiral galaxy M81, it measured the distance of the galaxy to be 11 million light years, which is 3.4 megaparsecs. Yes, I got technical. They quote a 10% uncertainty in this result, of course, plus or minus 1 million light years. Next, we have the blurred vision. Yeah. December 1993. I know, it was during 5 spacewalks. Wait, what'd you say, Jason? Each black hole, does each have a black box in case accidentally blowing itself up? Maybe. Maybe, who knows? Yeah, I know. Now we know that most galaxies have big black holes in the middle. Yeah, they're called supermassive black holes. But what happened before space-time began? Tell me that, you here. Checkmate, atheist. Actually, I'm going to get into that on a future show about the Big Bang Theory. Not the TV show, what astronomers call the Big Bang Theory. Where was I? Oh, yeah. I was talking about the blurred vision. I think my glasses are blurry, too. Basically, during 5 spacewalks, totaling 35 hours and 28 minutes, in case anybody is a NASA nerd, astronauts actually completed the very first surfacing mission. 2 teams of astronauts installed and placed 10 instruments, including the COSP-ST, actual replacement, the CoStar, and the WFPC-2, the wide-field planetary camera, and they also corrected the flatness of the mirror's outer edge, which basically meant when it was being polished, flat, they actually corrected that. Time to talk about glasses for Hubble. Yay! Yay! Hubble can see now. Oops. I mean, additional upgrades, and when they did the upgrade, they put on new solar arrays, new solar drive electronics, new rate center units, 2 gyroelectric control units so they can keep it in orbit a little bit, and about 7 or 8 electrical fuses. I forget exactly how many that was. They also installed 2 magnetars. The mission, basically, yep, it was a success. Woohoo! They captured the, basically, this is one of the astronauts. I forgot which one this was. Sorry, I should have mentioned him. This is the repair unit when it was going over here. Sorry. This is the wide-field planetary camera 1 and wide-field planetary camera 2. 2 of the new cameras they actually installed. The wide-field planetary camera 2 is Basically, it's a range where we cannot see with our own visual eyes. If you look up in the sky, you see what you see, but if you use a different spectrum of light on a different camera, you will see a whole lot different color shades. Yeah, I know. We're very limited to our own visual sights. Nuclear location of the soul, it changes everything. Hey, Lady Q. Let's see, they added magnetars. Why? So Hubble can make popcorn while watching the universe. You know, that's actually a good idea. Go up there, make some popcorn. Yeah, if the radiation doesn't kill me, but I'll enjoy the popcorn first. Evidence of supermassive black holes were actually confirmed, like I talked about, but they actually were confirmed in every single major galaxy. The STS astronomer Holland Ford and Richard Harms, the Applied Research Corporation, they used the telescope's Wide Field Planetary Camera 2, the new one they installed, to take an image of the Whirlpool Hot Galaxy. I'll give you a little closer look at this right here. This is pretty cool. They saw the optic spectrograph is used to measure the speed of swirling gases. They showed that there was not enough mass in stars to account for what the tremendous gravitational field, basically pulling it all into a huge whirlpool shape. Black holes, by definition, they cannot actually be seen, as their gravity is so strong that even light cannot reach escape velocity or be reflected. The supermassive black hole discovered at the center of M87 was calculated to be as massive as 5 billion of our own suns. It's concentrated into space no bigger than our own little solar system. That's how massive this black hole is. The next discovery that Hubble I want to talk about here today. What'd you say, Violet? Yes, I know magnets are the same as magnetrons, but I wanted to make the joke. Yeah, ha 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 ha. Okay, let's go back to Hubble's more discoveries. Here's the spectrum of the gas. I wanted to show you. I forgot to show you that one. Sorry. You got me off guard mic for a second there. Okay. Hubble, many people don't realize this, but Hubble actually discovered one of the next objects that I've talked about on a previous show, which was the destruction of Shoemaker-Levy 9 comet. Yes. This is the team actually watching the impact. On July 16, 1994, everybody looked at a new comet that Carolyn Shoemaker and Gene Shoemaker and David Levy used. They discovered this. They watched the telescope here. They looked at the Hubble telescope and they watched the impact of the Shoemaker-Levy 9 comet right at the impact of Jupiter. As you can see right here, the comet broke into 21 fragments. Yeah, it was so heavy. Jupiter's gravitational pull basically pulled it all apart. This is an actual Hubble image of Shoemaker-Levy 9 being broken apart. Let's see. Some other people may be familiar with this next object called, I just lost my place, called Gas Pillars of Hercules. The Pillars of Creation, sorry. I don't know why I said Hercules. The Pillars of Creation. If you didn't know what the Pillars of Creation are, they are located in the Eagle Nebula. This image was taken by the Hubble's Wide Field Planetary Camera 2, the WFPCO2. Where was I? Oh yeah, here it was. I'm sorry, but that still got me though. Yes, I'm going to read the chat. Okay. I have seen a theory where every black holes shared are the same singularity as their core. Don't think they do, but very interesting nonetheless. That is another theory. Yes. Going to do some Batman and American Pie. I know. It is such an amazing coincidence, Joseph. The comet that crashed into the Jupiter is named after the comet that people actually discovered. It's wow. See, China had better turn the craft around and snap a picture of the Earth because NASA won't do it for the past 20 years. I totally agree, Jason. China does need to do that. They have pictures on them landing on the moon's surface. We haven't had a picture of Earth in years. Well, speaking of years, look at this image right here. Do you guys recognize this? This is the Hubble Deep Field image. This was taken basically a couple days long, 30 days long, 10 days long. Sorry, I had to get it right for a second. If you're unfamiliar with the Hubble Deep Field, this is how they discovered it. They looked at the Big Dipper. They focused the telescope at the Big Dipper, just a little point north, and they zoomed in even more. To give an example about how big of the patch of sky was that the Hubble Deep Field took, take your arm at arm's length, hold a grain of rice. That piece of sky the grain of rice covers, that's how much of the sky Hubble took a picture of. In this picture itself, every single dot is a galaxy. I just love this picture. This is one of my backdrops, so forgive me. Another one on March 7th, 1996. For the first time, we saw Pluto. Yes, we had a little fuzzy ball. This was the very first image we took of Pluto in March 7th, 1966. I mean, you can see it's a ragged north and polar capped. We were very close to this, but this image reveals distinct features, basically include a range of polar caps, dark stripes, bright spot, even seen rotating at the planet. On February 11th, 1997, Hubble decided to expand the view. Let's see, did I actually, no, I forgot the astronauts' names on here. Oops, I forgot to put them on the screen. I'm sorry, guys. But they did replace the Goddard High Resolution Spectrograph and the NICMOS, which is the near-infrared camera and multi-object spectrometer. They swapped out the spectrogram with the Space Telescope imaging spectrogram, basically to take more detailed pictures of celestial objects and to hunt for black holes. This mission was considered a success. It went on to analyze light of the glowing glass rings around supernova 1987A, seen to ride nebula in infrared, and detected the signatures of a supermassive black hole in M84. I mean, basically, peering halfway through the universe, they got a chance to analyze light from exploded stars that died long before our own sun even existed. The Hubble Telescope allowed astronomers to determine that the expansion of the cosmos has not since slowed down since the initial impetus of the Big Bang Theory. Oops, sorry, was that a big word for you guys? Okay. I mean, yeah, we'll be talking about the Big Bang Theory. So, basically, these images here showcase 3 of the supernovas used to actually basically pinpoint the faster rate of expansion of the universe. False color images from the observed observations by the Supernova Cosmology Project is one of the two most distant spectropopity confirmed supernovas. And excuse me, I need to take another drink of my Nibble soda. And where was I? Except 2 of those dots, they're stars in the Milky Way galaxy. I apologize. Thank you very much. Yeah, 2 or 3 of those dots were stars. Rest are all galaxies. And no, they did not find. They did actually find a galaxy far, far away. They found several far, far away. I know you need to know your term. Nominal. So I just can't talk today. I don't know why. But I was talking about Hubble Telescope using the sharpest view yet. Yeah. This is the glowing loops gas called the Ring Nebula M57. See, I told you I can't talk. The French astronomer Charles Messier, how do you pronounce his name? He first discovered it about 200 years ago. This picture here, this one right here, it reveals that the ring is actually a cylinder of gas almost seen on end to end. I mean, because of the thickness of gas, dust form a waste around the dying star, and of course, this waste slows down the expansion of material ejected by the doomed object. This image was taken here on October 16th, 1988. And another discovery Hubble has captured was an expanding bubble. Yep, they saw an expanding bubble of gas. This star was let me actually show you guys here. Easier, okay. This star was about 40 times more massive than the sun blowing a giant bubble of material into space. This picture right here is the bubble nebula known as NGC 7635. That beefy star in the lower center in the bright blue bubble. It's basically, it's so hot that the gas is shedding almost so much material in space. It's surrounding the bubble itself. The bubble it's basically, the bubble, how do I describe the bubble? It's kind of smooth, not like soapy bubbles, but very thin. The thickness is about 6 light years wide and expanding about 4 million miles per hour. That's a fast nebula. If you're wondering how close this is, you can't get really close to see it because it's only 7,000 light years away. Look up in the constellation Cassiopeia next time you get a telescope. You might be able to spot something similar like that if you have a very good telescope. Oh, that's why I don't eat Taco Bell, Vile Mike. Oh my gosh. Lady Q, you gotta stop eating Taco Bell. Oh my gosh. Hubble's gonna discover you guys. Of course, this is an artist's interpretation right here of a giant gas planet, not the result of eating Taco Bell. I hate Taco Bell. I do not advocate Taco Bell for anybody unless you really have the munchies or hungry. Well, I could not find the actual image because they don't have a clear image, but this is actually an artist's impression of the gas giant orbiting yellow star called T09458. It's 150 light years from Earth. I hate it when I do this. That's the wrong button on my computer here. Only 7,000 light years. Sure, I'll go there and back a few times. Captain Trek, if you do go there, can you make sure that you give us that nice space gold? Cassiopeia. Yeah, it should have been called Cassiopeia. Let's see. Hubble unveiled this right here is NGC 2047. This is when Hubble reached its 100,000 orbital milestone. When it reached over 100,000 times around the orbit of Earth. It took about 18 years to do this. And I did it again. Hubble has actually seen the farthest star ever. Yes, we talked about this, 11 Light Shack. Galaxy far, far away. Well, they actually found a very, 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 very far star. This star here is called MACS J1149 plus 2223. Icarus, otherwise known as Icarus, of course. Excuse me. It's a lens star 1. It's only visible because it's being magnified by the gravity of massive galaxy cluster located about 5 billion light years from Earth. This is why we can actually see this thing. NASA's Hubble actually found water vapor on a habitable zone exoplanet for the very first time. Yes, Hubble made a huge discovery. Water vapor on a planet in the habitable zone. If you're unfamiliar what a habitable zone is on a planet, It's basically the comfortable light this distance a planetary body can be from its orbiting star or orbiting gas giant. We call it the Goldilocks zone. Not too cold, not too hot, just right. Yeah, hot Jupiter is more attractive than the ugly Jupiter, but gravitational lensing for the win. Yeah, that's why I highlighted that one. Oh, where was I? Oh, yeah. To date, about 4,000 exoplanets have actually been found, and the majority of them are actually been hostile to human life and microbe life and all forms of life because toxic atmospheres, hot gas, odd orbital planes, radiation going everywhere, no planetary gravitational pull. Once again, the gravitational radiation, the core does not spin enough to create a magnetosphere to keep the solar away from us. I can't talk today. Well, in this picture right here, this artist's conception, of course, it's been identified in a planet that astronomers called K218b. It's located about 110 light years away. Although there is water, that means there could be rain and clouds. We're not sure if it actually has liquid water yet. It's also the right distance for the water to not evaporate or freeze. But don't go looking for real estate yet. You can't move there. Sorry about Mike, you can't move there. Why? Well, because the planet's not actually found in our own solar system. Yeah. It's too far away to go. It'll take you several decades to get there. And we have no actually way to get there right now. 10% solar burn secondary base observations. Not only about 4,000 actually confirmed. More than 4,000 confirmed that I know of. On October 16th, 2019, yep, we just jumped ahead in the future. NASA and Hubble observed the very first configured interstellar comet. Not one from our own galaxy, I mean, of our own solar system, but from another solar system that came from, where was it came from? The Crimea, not Crimea. Well, it was called 21 Borsval. I forgot where it actually came from. Let's see. I know the comet was about 260 million miles from Earth when Hubble took the photo of the comet. As you can see on the right-hand side, this is the actual picture of the comet. But I forgot exactly where. Sorry about that. Of course, in 2017, the first identified interstellar visit of an object formerly named Oumuamua. This is another one Hubble discovered. If you guys remember from our past shows called NEOs and Comets and Asteroids and NEOs, Oumuamua. Yeah, it's from 24 million miles from the sun before racing out of our own little solar system. Many people actually ask, what is next for space observations besides Hubble? Well, NASA has a plan. It's called the James Webb Telescope. Yep. NASA has officially, as of this morning, have an official launch date for the James Webb Telescope. It's been postponing and postponing and postponing. The official targeting date is October 31st, 2021. Yes, we actually have a launch date. I am so happy about this. The James Webb Telescope, as you can see here, the secondary mirror. I took a picture. Fine. The secondary mirror, it reflects gathered light from the primary mirror to the science instruments. It's huge, and actually, I did not want to bore you with all the details, because I already talked about the Hubble Telescope. But I'm going to put a link in the description for more information about the James Webb Telescope. It tells you about the size, the shape, how the mirrors fold down to a long 3 cone areas for easy to fit into the shuttle. Why hexagonal mirrors instead of a round solid mirror. I'm really looking forward to this launch here, and I hope to actually go there personally. And speaking of personally, many people in here said only 7. I already did that, right? Many people in here are personally in here physically right now, and I want to thank everybody for joining me today on what we ask, hey, what's up with the universe? And I want to end today's show by quoting Edmund Hubble himself. He said, equipped with his 5 senses, man explores the universe around him and calls the adventure science. I want to thank everybody and have a good night, or good day, or good afternoon.